Okay, everyone, so we're going to carry on with Unit 2 today for doing world issues. So this is human population, and it's kind of a big unit, so we're going to do our best to get through all of it this week. I know, heavy unit, a lot to do, so we're going to do our best to get through it. So let's talk about human population. So as of today, the current population of the world is, I believe that's 7,800,672,950. If I can read my numbers right, it's very hard, but that is constantly in flux and constantly changing. There's a website you can watch if you want about the changing of the population counter. You can actually watch it change up and down if you want. So there you go. You do have that. This is actually a map of what things would look like if the population was based on landmass. So each country has a land based on how much population they have. So you'll notice Canada is actually a lot smaller than the United States, for example, because our population is that much smaller than the United States, because we're actually more land than people up here. And you see Alaska is very tiny right there. The United States is much bigger. California is gigantic because a lot of population lives in California, and New York City as well is very large. And you can see all the different countries and how big they are and how small they are. Here is the rest of the world. Note China and India have giant populations because they are the two biggest populations. So you can see here that just how large that they are. And here as well. Russia is actually relatively tiny in terms of population based on land mass, and how much bigger the UK is based on that as well. So there you have China and India there. So what is demography? Demography is technically the study of human populations. That's the official terminology for it, and that's what we use it for. It's used by the government to figure out things like the need for schools and hospitals, housing, roads, labor, also how many products that we need for people. It's used by geographers and social scientists to explain changes as well in communities. That's why they do census every year in different countries. They come around and find out how many people are living in your house or how many people you have in the area. So that is what we do. People study populations. This is what they do for a living. In this unit, we're going to look at two very real trends. The fact that the population exploded from the 1600s to today, and in how in 1960 our population hit 3 billion. And it took us 1 million years to get that high, but it only took us 39 years to get to 6 billion. So we're going to look at that. And the fact that the growth rate of the population has significantly shrunk since the 1980s. So even though it's exploded, it's also started to decline as well since the 1980s. So why is that? So why are these two trends? Why was there such a big explosion, and now why is there backtrack on it? So we can see via the graphs how the population explosion has happened and how slowly and how long it took us. If you know this here, starting out and then moving on, and we see a dip with the Black Death, the plague, and then we're into the modern ages now. And then over here you can kind of see it a little better, and how industrialized countries exploded faster, but have now kind of tapered off, whereas developing countries have continued to climb steadily. And we'll talk about this and why this is. So the declining growth rate. So it only took us 12 years, so 87 to 99, to get from 5 billion to 6 billion, which is an incredible jump. And it will take us 6 more years from now to get to 8 billion. So we think, we were projecting, we reached 7 billion in 2011, so the world population should reach 9 billion by 2042 if the numbers hold true. So we notice here projected population rates. But we do see it's going to start to potentially taper off, maybe, and we'll see why. So what do declining growth rates mean for countries like Canada? Now, when we talk about this, we're going to kind of see more of this with population pyramids, in terms of which kind of gives you a visual representation. So So how do populations change, and what affects populations? So there's kind of, if we're going to do a little bit of a history lesson here now in terms of technological change and population growth. So stage one is hunting and gathering. We know if you've done any history or you did the grade 12 world history, or sorry, grade 11 world history, you probably would have talked about this, but early man were foragers. And life consisted of looking for food, traditionally called hunter-gatherers, and they were the ones that were out looking for food at the time, and it was kind of a tough life in stage one in hunting and gathering. It was not an easy life for people. You died fairly young, and had to fight wild beasts. Food was not a guarantee, so there was not enough food. The population did not grow. Carrying capacity was low at this particular time. Large amounts of land were needed for relatively few people because you needed places to grow, you also needed places to hunt. And so this kept populations relatively small. So what do we need before a population can grow then? We then get into the agricultural revolution, which was stage two. So, and because of this, the movement of peoples, the diaspora, if you will. And so this is when we start looking at what starts building a bigger population. So we have food surplus. If we have more reliable food sources, there's less starvation, improved health, and longer life expectancy, i.e. more population. And because of the food surplus, we can also have job specialization as well, because not everyone needs to hunt for food. You can do other things as well. Now we also get people gathering together, so we get the beginning of cities and towns, with the introduction of trade, you get people starting to write things down. So this is a growing complexity of society. So food allows us to, I guess, essentially become more complex, as well as to live longer as well. Less physical work is needed. This means movements to cities, more workers for factories, and during the Industrial Revolution, the invention of the steam engine was a huge part of the reason for population explosion. So we need to think of two worlds when we're talking about demographics, absolute and relative. So in absolute, in 2013, Canada had 393,973 births. Is this a big number? If that number of babies were born in China, it wouldn't be. Why? Because it's the absolute number, but we're not putting it relative to Canadians' current population, which is 36.29 million. This means the relative birth rate is approximately 10.3 births per 1,000 people. This is more useful than the absolute number. You have to put it into context. These numbers are meaningless unless they're put into context of the country. Some more demographic terms we need to know. The birth rate. So this is a little bit of math here for you. The number of births of a country for every 1,000 people. So, for example, if you have 150,000 born in a year in a country with 5 million people, the rate would be 30 per 1,000. Because what you do is you take the number of births, divide by the population, times 1,000, you get 30. So over 30 is high, under 15 is low. Canada is at 10.3, roughly. The death rate is the opposite of this, obviously. How many people died divided by the population times 1,000. And so equals 20 in this instance. So over 30 is high, under 15 is low. Canada's death rate was 8.7 in 2017. So that's pretty good. So that's how we calculate the birth and death rate. The natural increase rate, therefore, is the difference between the birth rate and the death rate. So pretty easy for this one. In our country of 5 million, 30 per 1,000 birth rate, 20 per 1,000 was the death rate. This means that the natural increase rate is 10, because you take the birth rate minus the death rate. That's what you get, which is roughly 1%. Developing countries have natural increase rate of less than 1%. Developing countries have one of higher than 2 normally. We are at 0.3. Our population is relatively stable. The immigration rate is obviously very, very similar. The number of immigrants divided by the population times 1,000. Emigration is the same thing. Emigration is leaving the country. Immigration is coming to the country. And then the net migration rate is the subtraction of the immigrants from the immigrants, and you get your subtraction rate. So the population growth rate, the rate at which a country's population is changing, this combines the net migration and the natural increase rate. Most countries care about the natural increase rate than the migration rate, but Canada does not have a high enough natural replacement rate, so we have a lot of immigration. So that's why we care more about that term as opposed to dependency measures. So dependency measures are used to compare the populations in the dependent ages of 14 and over 64. So these are called dependent. So that means they're living, they're relying on other people to survive. There are some people who work younger or older, but these are generally not the working ages. So you don't work before you're 14 and you don't work after you're 64, generally, in general. So we have to look at a few statistics for this. So the dependency load and the age dependency ratio. So the dependency load is the percentage of a country's population that needs to be supported by the independent. So whether it's too young or too old. In Canada, 17% of the population were younger and 14% were older. That means the dependency load was 31% because we have to carry both younger and older. The age dependency ratio, so this is the ratio of how many dependents there are for every working age person. So the population of 14 and under plus the population of 65 and over divided by the population is, so 15 minus 64 times 100, so roughly about 48.2 in 2016. So that means there are about 48 people in the dependent ages for every 100 persons in the working age. So that is not good. That means 100 people are relying on only 48 people to support them, which is not great. The infant mortality rate is the number of children who die in the first year of life per 1,000 births. So over 80 is very high, under 15 is very low. Ours was roughly 4.5. Life expectancy obviously is the average life from birth to death. Short is less than 50 years, long is over 75. We are just now over 81. The American life expectancy has actually gone down considerably. Wonder why. Total fertility rate is the average number of children that each woman in a country will have in their fertile years. This is about 15 to 45. High is more than 5. Low is under the replacement rate, which is 2.1. Canada's is 1.6. So roughly 1, sometimes not. So the replacement rate then is the total fertility rate that produces a natural increasement rate of 0. And a rate of 0 means the population will not grow. But we're not considering immigration in that instance, but we do. So rule of 72. This is a way we can figure out how long it will take a country's population to double. You can divide 72 by the country's growth rate. So 72 divided by 2.3 equals 30. So for example, it could take 30 years for countries to double. The rule of 70 and the rule of 72 give a rough estimate of the numbers of years it would take. When using the rule of 70, the number 70 is used in the calculation. Likewise, when rule of 72, the number 72 is used in the calculation. Population pyramids. So we're going to get a little more familiar with this because this is going to be your assignment for the week. So population pyramid is a type of graph that gives you a quick image of what a population is made of. It's a visual image of that. It's broken down by gender, age, and group, and can be used straight numbers or in percentages. So it stacks. It usually starts at the bottom here, and it works its way to the top here. So this is over 95 to 99 years of age, and you usually have male and female, one on each side. So you see, this population has a lot of young, very, very young, and not a lot of old. So this is a special type of graph that summarizes the age and gender and structure of population. Each bar indicates the number of percentages of people in a particular gender in a specific age group. For example, 15 to 19 are shown in green, and females 15 to 19 are shown in brown. So it's comparison to males and females. In general, population pyramid has a triangular shape, wide at the base, narrow at the top. The shape results from the fact that it begins with the young and ends with the very old. So that's traditionally why. Okay, so that is it for basic terms and terminologies in world populations. I've kind of shuffled you through that pretty quick, but is kind of just a lot of knowledge and content based. Okay, that's it for me. Apologize for the mask, but I'm still a little sick, so I'm going to wear the mask a little bit longer. Okay, guys, that's it for me, and we'll see you in the next video.